Okay, let's take a look at what we call the law of sines. It's a relationship between the angles and the sides opposite them. So here's what it says. It says the sine of A, so in other words, if I take the sine of this angle here, divided by its opposite side, that ratio, let's say that I take the sine of this angle, say it's 42 degrees, divided by this A over here, which let's say is 10, and I get something like, 0.126. That means this will be 0.126, and this will be 0.126. You'll get the same ratio. So the sine of A divided by its opposite side will equal the sine of this over its opposite side, which will also equal the exact same ratio of sine of this C over its opposite side. Let's take a look. And so let's see what's true here. So here's what I would say is true, knowing the law of sines. So if I take this right here, there's its opposite side. I know the sine of 50 degrees over its opposite side will be the same ratio as the sine of 60 over its opposite side, which is what? A, which will equal the sine of this angle, 70, over its opposite side, which in this case is B. That's what I know is true. Now, obviously, we're going to do problems where I have a number here and I put it in here. Obviously, you're not going to set up three pieces all equal. You'll set up just, this guy's equal to this guy, or maybe this one equal to this one, and solve it. So let's look at an example. Now, a few things I want to say before we get going. I'm going to keep things, we're not going to study what's called an ambiguous case where you could end up with two solutions, or it's possible to where, this triangle doesn't exist. If we end up getting an error when we do it on the calculator, we're just going to say, hey, unknown. Don't worry about it. We're not going to study those cases. We're not going to this year going to get that far into it. I just want to expose you to the idea. So let's look at this example. So what do I know is true? Now I have two angles. It's not a right triangle, so I'm not going to use the SOHCAHTOA. So I'm like, hey, I want to find this question mark over here. So I know the sine of 48 degrees over its opposite side, which in this case is the question mark, the unknown, is equal to the sine of 58 degrees over its opposite side, which is who? 15. I know that those are of the same ratio, so I'm going to set them equal. Both of those come out to be the exact same decimal value. So let's go ahead and use the means extremes. Cross product, as we like to say, equals 15 times the sine of 48. I want to solve for x, so I'm going to get rid of sine of 58, which is just some number that we could look up, divided by the sine of 58. So I now need to go to my calculator to do this, obviously. So I'm just going to go online, and right here I have a calculator. Now, number one, change it to degree mode. You cannot forget to change it to degree mode. So we need to do 15 times the sine of 58. Sine of 58. I'm going to go ahead and just hit enter, and then I'm going to say divided by what? The sine of, was it 58? No, I messed up. Let's try again. Sorry. So it's 15 times the sine of 48 is what we had. Let's divide that now by the sine of 58. I have my numbers backwards. Hit enter. So we get that, hey, x is what? 13.1? We'll just go with 13.1. That's good enough for me. To the tenths. So we know this missing side here is about 13.1. That's its length. Now, what if we have this? Again, notice you have two angles. You have 78, and you're looking for an angle. So this time, what we're going to do, we're going to say, hey, sine of 78 degrees over its opposite side, which is what? 9, is equal to the sine of, well, we don't know the angle, over 7. There's only one missing piece here, so we can figure this out. So I'm going to say, hey, 9 times the sine of theta is equal to 7 times the sine of 78. And then we divide by 9. Divide by 9. Well, I need to go ahead and do this. So here's what I have. Sine of theta is approximately whatever this is. And then what are you going to have to do? You're going to have to take the inverse sine. Remember, if we're ever trying to find an angle, you're going to have to use the inverse button. So we want to do 7 times the sine of 78 divided by 9. So let's go back to our calculator, clear out. We're still in degree mode. That's good. 7 times the sine of 78 divided by 9.7607. So here's what we have if we went 0.7607, blah, 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 blah. It goes on forever. So what are we going to do? We're going to come in here and take the inverse sine of both pieces, and that will give us theta. So if we come back to our calculator and we want the inverse sine, so I hit inverse sine, and I want it of that. Now it shows you, hey, 0.76, or you can just use this little answer. So it's going to give us the arc sine of our answer, our last answer, which it says, hey, that was 49.5 degrees about. So 49.5 degrees is my angle. There are two examples. You're either finding the angle or you're finding a missing side. Now, a lot of times when we're finding the angle, if you get an error, just say undefined or just can't do it. You might get that on one or two of the homework problems. That basically means, hey, there's two possible answers here, or this triangle can't exist. Okay? Now, here are two things I want you to remember. Sometimes the angle doesn't exist because the triangle isn't possible, or the angle could be two different things. Again, we're not going to study the ambiguous case. Here's the other main thing, and this is important. This really seems to help students. If you have two angles in the problem, you'll recognize that it's going to be a law of sines problem instead of a law of cosines. The law of cosines is only going to have one angle in the problem. But if you see two angles, whether it's an unknown angle and another angle is given, as soon as I see two angles in the problem, I know it's a law of sines problem. Okay, because a lot of times we get confused. Oh, do I use law of sines or law of cosines? Law of sines, if I see two angles, that's who I'm using.